nation. So think about if you have a career in the future. Although Professor Xu, he already presented to you. Think about what's your purpose for study. Not just a major, but somehow you can focus on something here. You can think about in the future the trend of the world. You can see that there are so many opportunities for you. There are 10 major technology will happen in the near future. I think one of the most big things here you already heard about is the AI technology. That is digital, and the digital transformation is very important in every industry right now, not only in the electronics industry, but also in all kinds of industry, chemical engineering, our car manufacturing, everything, including AI. The digital transformation is quite important. The second one is the population booming in the world. So we are going to have more than 8 billion people in this globe to live here. In Taiwan, people are getting aged more, and we have more aged people, and so medical is always a problem. So you can think about there's a big need for healthcare, and all of them rely on some materials and energy. You can think about that's the major part of how you have to encounter in the future. That part is chemical engineers and material science can do. Because we are going to develop better material for the biomedical use and also for electronic use. And even for AI, we are going to build out the server, build out the chip, to produce all the equipment for the manufacturing. Probably is related to mechanical engineering, but they still do need good materials for the equipment. And also we are designing a better material for chip design. And think about that. As a chemical engineer, we can deal many different aspects. From this side, you can think we are actually magicians as an engineer. We are actually magicians here. We are doing not only the big plan, but also we are working on something very small from the material, the nano size. For example, yesterday I just introduced you about the nanomedicine, which is requiring the nanomaterials as a parent drug. And somehow you are going to need a larger thinking, not only for the with a major, but you are thinking what you need for the future. So that's quite important. And also, of course, you are going to do the mass production. So all the engineering students have to think about the link with industry. So not only the chemical part, or the material science, then we are not only for the chemical industry or material industry. We are everywhere. Some of my students, they are working in pharmaceutics. Some of my students are working in this is the computer design for the heat removal problem over there. So and then you can see even TSMC, they require chemical engineer to do the process development. So they need a lot of chemicals over there to treat them and to produce their IC. in the training here, you are learning from the basic. There are some courses you have to learn, but in fact, we are going to develop skill for the future practical needs. So this is the scope. Sorry that we don't have that in English, but you can take a look. If you do have a problem, I can explain to you. Most likely in chemical engineering and material science, we have the basic of mathematics, that is calculus, advanced engineering mathematics, that is about the ordinary differential equation and the partial differential equation, and so on. We have chemistry, a whole series of chemistry, like basic fundamental chemistry, inorganic chemistry, organic chemistry, biochemistry, and also at the end you are going to have biochemical engineering. That's why you may do the fermentation in the lab, and like Professor Lan, he can make a beer and produce beer in the lab. So it's all kinds of related to the bioengineering. And also we have physics, and we have physical chemistry, and then we have solid state physics, and we have material science, and all the materials rely on the solid material. And you can think about traditionally in chemical engineering, we are working on fluid more, that is gas, and the solvent and the liquid. So you can use them for the material processing. But for the material scientists, they are working on the solid material, like this is a silicon nitride, our 5G high frequency material, and so on. And then, so with the solid background of the math and chemistry and physics, and something about the biochemistry and the biology. So you can develop all kinds of skills for biomedical application. And then in terms of chemical engineering, we have one more thing that is transport phenomena. We're dealing with fluid mechanics, mechanics like mechanical engineering do. We have thermal, it's a heat transfer, and they are all related. And in fact, they are mechanical engineers also learn this kind of work. We have a thermodynamic, that is just very fundamental, so you can analyze the energy problem. So, and then at the end, we will have some of the, this is the final project, so to finish as a, capstone. We have a capstone courses. Yeah, let me have a seat. I understand it. Okay, this is the structure for the regulation for the taking. I think this is the regulation set up in our program, so we can discuss later. But I don't want to go to too much detail. And also here for the capstone process for our international program in English for engineer. Then this is an innovative engineering system and component design. So originally it is taught by Professor Yusen Zhang, but she's going to retire. So I'm going to have a new professor to take care of this course.